Battery electric vehicles are slowly but surely gaining ground around the world. Many countries are already planning to phase out internal combustion engine cars altogether. And while Australia has been a bit slower off the mark, things are finally starting to move. But some believe the future of driving isn't just about full battery electric vehicles. Companies like Hyundai and Toyota are betting big on hydrogen, a fuel that could one day power everything from passenger cars to long-haul trucks. So could hydrogen cars be part of Australia's transport future? Welcome to RAC's Horizons podcast. I'm Mike Bartlett. Joining me remotely today to talk about what a hydrogen-powered future might look like is Scott Nargar, Senior Manager of Future Mobility and Government Relations at Hyundai Motor Company Australia. Welcome, Scott. Thanks for joining us.
It's great to be here.
When people talk about the future of cars, most of the talk seems to be about EVs. They're certainly cheaper and more common sites on the road now. You don't think it's necessarily a one-horse race, though, do you? Why are you so interested in hydrogen?
Yeah, I think the industry globally is looking at a range of technologies to help decarbonise transport, and hydrogen is one of those technologies that Hyundai has been working on for over 25 years now. And we know several competitors have been working on the technology for just as long. When we look at the decarbonisation of transport, there's a couple of different thoughts. Passenger vehicles traditionally will be using electric vehicles and batteries to propel themselves around. And larger vehicles like trucks and buses, trains, ferries and ships will look towards hydrogen. It's almost looking at the difference between petrol today and diesel. Diesel generally used for larger capacity vehicles where you've got to shift more weight around. So hydrogen's a much better technology for that.
So I think the idea of a hydrogen-powered vehicle is one that people are more or less clear on. For those that are less clear, how does a hydrogen fuel cell vehicle actually work?
A hydrogen fuel cell vehicle works very similar to an electric car. In a case of a hydrogen vehicle, we store the energy as gas in the tanks, and in an EV, it's stored into a battery. In a hydrogen fuel cell vehicle, we've got 6.33 kilos of gas in 3 tanks in the back of the car.
Okay, and why are people so excited? I guess I'm thinking about people who are backing EVs. What is it about hydrogen fuel cell technology that is so appealing?
One of the biggest differences today is the range. So with some of the fastest charging cars in the world, which are the Hyundais within the Hyundai Motor Group and Porsche, they've got 800-volt batteries that can charge at, or using 350 kilowatt stations. So they can charge from 10% to 80% in about 16 minutes. A hydrogen fuel cell passenger vehicle, I can get the gas into a car in about 3 to 5 minutes, and the cars will do around 650 to 700 kilometres, where EV today around that 550 to 650 kilometres. So it's a faster charge and a longer drive.
Okay, so it's an end, hopefully, to range anxiety that many of us who drive EVs have experienced when leaving the city. But the hydrogen fuel cell technology, it is more environmentally friendly, so it will appeal to the people who buy EVs for that reason?
Yeah, we're using a lot less critical minerals. So there's a lot of technology goes into the big batteries in EVs. So you've got lithium, you've also got copper and cobalt and other critical minerals there. In a hydrogen fuel cell vehicle, we do have a high voltage battery. It's a lot smaller. It's usually 1.5 kilowatt hours. Some of our EVs today have got 88 to 110 kilowatt hours of battery. So they're significantly smaller. And in the fuel cell stack, we use platinum and also some other materials, so carbon and in the anodes and cathodes and in the membranes. So there's a lot less materials going to a fuel cell stack than into a battery. So we can get a lot more fuel cell cars made with those critical minerals that go into batteries than we need to in a fuel cell vehicle.
Okay, so it's not just a question of less emissions, which obviously would put them on a par with the EV, it's that they're using less critical minerals and materials just to make the cars in the first place.
That's correct. And it's one of the things that we find the technology to be very complementary. The electric motors in our hydrogen fuel cell vehicles is exactly the same as the part number in our Kona EV. A lot of the control boxes and systems in the car are exactly the same as EVs as well. And really, we're using the hydrogen in the tanks to go into a fuel cell stack. It goes in at very low pressure, so it's stored at high pressure, goes into the fuel cell stacks at very low pressure. In fact, it goes in at 1.6 bar. The air pressure we feel around us now is the pressure that's injected into the stack. And from there, there's a chemical reaction that takes place. And all we're doing is a reverse process of how we've made the hydrogen. So hopefully we've used renewable energy and water to make the hydrogen. The fuel cell stack in a car is reverse of that. It's actually taking it, it's breaking down the hydrogen back into energy, which powers the vehicle. And then the byproduct is water. The best thing about that, we also need purified air to run the fuel cell stack. So we take 99.9% of all the ultrafine particulate matter out of the air. We use that during the chemical reaction, then air is put back out into the environment, purified. So not only is the vehicle not emitting any emissions down the tailpipe, it's actually purifying the air as it goes. So there's many more benefits than just being a zero emission vehicle. There's also that air purification factor as well.
That's amazing. I mean, you mentioned vehicles on the roads in the ACT there. I mean, what does the current market look like? How many hydrogen-powered vehicles are there on the road at the moment?
Yeah, in Australia, there's about 100 hydrogen-powered vehicles running around. There's our vehicles, the Hyundai NEXO SUV. There's a Toyota Mirai. BMW had some vehicles here for testing. They've got some more vehicles coming to Australia. Photon's got some trucks here in Australia. There's also some companies that got some buses in Australia as well. The market's pretty low at the moment because infrastructure is the core to all of this. Without infrastructure in the right locations and the right type of infrastructure, it's very hard to deploy big fleets of vehicles. An example is the hydrogen station in the ACT has been there since March 2021. It's a great station. It's been built with the least amount of money I've seen anywhere in the world. It was a very high budget for that project. And the problem with that, it had no redundancy. So when anything went down or the technical problem for the station anywhere, either a hardware or software, that station went down and it wasn't making hydrogen. So the vehicles coming to it couldn't fill up. So one of the key things we ask for government and also hydrogen station proponents or projects is to build in redundancy. Most stations I've used across Europe have got redundancy built in because you want to keep that consistency of flow of the hydrogen.
Okay. Could you just unpack that for me a little? What do you mean when you're talking about redundancy there in the stations?
Having two of everything. So having two dispensers, two compressors, two electrolyzers,
right.
Two of everything in the whole system. So if there's a glitch in one system, the redundant system can take over and keep producing hydrogen and then keep compressing and dispensing in the vehicles. If you don't have that, you really want to have your station around a cluster of stations. So if you look at any of the major cities in Germany, Frankfurt, Berlin, Hamburg, Stuttgart, they've all got 4 or 5 or 6 hydrogen stations in around the cities now. That's happened over the last 5 or 6 years. And now what they're doing in Germany, they're linking those cities with more stations on the autobahns.
There's only around about 100 hydrogen-powered vehicles on the roads, you said there. I mean, is there not a sense that the EVs have just overtaken this mode of transport? I mean, why would two major global car companies, Hyundai and Toyota, be so interested in this process at this stage?
I think it's the opportunity of having a differentiation of fuel. So the electricity in some places in Australia, we can't get enough electricity to regions, especially in regional areas. With hydrogen, we can make it, we can store it. One of the big benefits of hydrogen, and especially seen in Germany, when they've got curtailed renewables, so they've got a lot of on and offshore wind and they've got onshore solar, they have a lot of excess energy during certain times of the year and during certain times of the day. So hydrogen manufacturers have paid money to take that excess energy off the grid and they're making hydrogen, which can be stored in gas pipelines. They can bleed the hydrogen at 25% against natural gas in their pipelines. They can store it in tube trailers. They can convert it to ammonia. So there's a number of ways to store and move hydrogen around where it's far harder to store energy in Australia. We're building mega batteries and they're hundreds of millions of dollars each and they've got to be replaced every 10 years. Hydrogen is another good way of storing excess energy, especially excess renewable energy. So it's one of those complementary technologies to help Australia and the world as we transition to a low emission or zero emission transport future. I think one of the problems is everyone's looking for a winner. And probably the best way to describe it is everything that runs on petrol today will more than likely be EV in the future. Everything that's running on diesel today will more than likely be fuel cell in the future. You will get that combination, and we've seen it with Mercedes-Benz back in 2019 at the Geneva Motor Show. They launched a Mercedes-Benz F-Cell, which had a big battery and also a hydrogen fuel cell stack. Now they've got a Mercedes-Benz badge so they can afford the charge for 2 expensive technologies in one car. But that really showed that you can have the 2 technology cars doing 1,200 kilometres. But you did say that the technology is advancing in electric vehicles, and we're seeing that. And certainly Hyundai itself has got much bigger batteries in our cars. We're getting much more range out of our vehicles, which is putting pressure on hydrogen passenger vehicles. But certainly when we get to heavy vehicles, it's a whole new story. You can't put enough batteries into a prime mover, especially a multi-combination, a prime mover with a couple of trailers on it, and drive it between major cities in Australia.
Okay. So from an Australian point of view, hydrogen makes a lot of sense because you can say we can ship it out to remote outposts and people can refuel more easily than they could recharge. But you also think it's possible that we're heading towards a situation where we're going to get hybrid vehicles that'll be part hydrogen and part EV.
Yeah, we'll see that coming, and you'll also get hybrid types of EV as well. So we know that Hyundai's announced during their some of their investor forums this year that electric EREVs, range extender EVs, are coming. So they'll have a small petrol generator. That generator is not actually propelling the vehicle; it's actually just generating electricity to charge the battery. So we go to vehicles close to 1,000 kilometers of range using a very small petrol generator. You can charge at home, or you can fill with petrol or whatever fuel it might be using, and you can get exceptional range out of those passenger vehicles. In trucks is a bit different. One of the things in Australia too, with trucking, they've seen it now with 40-ton rigid trucks that are on the road in Australia. These are 40-ton electric trucks. They take a considerable amount of time to charge up. So we know that freight operations in Australia, every dollar counts, especially moving freight around. It's a big country. And we know there's a lot of pressure on freight drivers to get from A to B as quick as they can, as safely as they can. They're going to take their regulated breaks, but they don't have the time to spend a couple of hours charging up every couple of 100 kilometers. That's where hydrogen makes a big difference. So hydrogen truck, we can fill up in about 10 to 12 minutes and get that truck back on the road doing between 400 and 800 kilometers, depending on the pressure in the tanks and the load on the truck.
You mentioned the cost there, Scott, and one of the reasons, of course, that EVs have taken off so much in the last couple of years is that they have become more affordable for most people, and part of that is that China is starting to dominate the EV market. Do you see something similar happening with hydrogen? I mean, what will it take to make hydrogen fuel cell vehicles more affordable?
We're starting to see that now in Australia. So Hyundai was one of the founders of the Australian Hydrogen Transport Forum, which spent the last couple of weeks down in Parliament. So it's Hyundai, Toyota, BMW, and Photon trucks. Photon is from China, and they've got thousands of those trucks running in China now. So everything comes down to the economies of scale. So the more you can build of the same things, you're buying the same parts from the third-party suppliers over and over again, so it becomes a lot cheaper. So we're seeing not only pressure from the markets in China with electric vehicles, but also now with hydrogen trucks coming in. And also we're seeing that hydrogen refueling stations have been manufactured in China now, and they're moving out to other countries in the Southeast Asia, but also coming to Australia now as well. So we see stations coming from the US and Europe now. There's some made in Australia up in Queensland by a company called H2H. But we're also seeing stations going to start arriving from China. And like we did with solar panels, we're going to see the price come down considerably.
Okay, so it's not just the vehicles themselves that might become cheaper, but the infrastructure that's needed to support them.
Yeah, infrastructure was prohibitively expensive over the last 10 years. We've seen just from when we went to tender with our most recent station to what the prices are now, it's come down in quite a big way. And it all depends what kind of station you want, whether you're taking a station that's just taking gas from a truck or from a facility and compressing it and dispensing it, or if you're making hydrogen on site and whether using grid power or renewable energy, there's big differences in the stations. There's also different pressures. In the past or over the last 10 years, cars generally run 700 bar of pressure, where trucks and buses and forklifts and trains and ships will run 350 bar. We're starting to see our trucks and some of our competitor trucks move up to the car pressure, so giving you not quite double the distance by going to a higher pressure and running those trucks. But the problem with going to a high pressure, there's a lot of complexity built in, and there's a lot of expense when it comes to operating those stations and maintaining them.
Going back to the environmental side of things, which is obviously a big part of the appeal of a hydrogen-powered vehicle, from a life cycle point of view, and I know you touched on the use of minerals and the fact that these are mobile air purifiers, which sounds fantastic. I mean, how does hydrogen itself stack up against EVs in terms of emissions? Obviously, a lot of hydrogen is still coming from fossil fuel sources. What's the emission situation like now, and how might that change as we move towards green hydrogen?
Yeah, you're correct. Most of the hydrogen in Australia comes from steam reformed natural gas. So the biggest supplier in Australia is Gas at Port Kembla, who actually makes hydrogen in Port Kembla, New South Wales, and it's sent across to Perth. Right. We are starting to see some renewable hydrogen projects coming on in Perth soon, and we're aware of the Woodside project down in Kwinana. So there is going to be a hydrogen source there, and I know that all the gas companies that currently have to send gas to WA will be buying it from sources over there. It may not be that source, but maybe other sources as well. the problem we've got here, and I'll use where I am here in New South Wales as an example, on average each day, 73 to 75% of the energy used to power houses and charge electric vehicles is coal-fired. About an extra 2% of that is gas, and then the remainder is hydro, wind, and solar. So we're still dominated by fossil fuels when powering electric vehicles today, unless you're lucky enough to have solar on your roof and you're parking the vehicle at home during the day, then you'll benefit from that. But then there's some awesome technology coming that way as well. We're starting to work on vehicle-to-grid technology now with our EVs and partner with some federal and state government institutions to test that technology and hopefully give the opportunity to have another vehicle to help decarbonise not only the road transport, but also our grid, and save taxpayers money instead of making these mega batteries, hundreds of millions of dollars on these super batteries, having a distributed battery set up by using people's cars. And then the customer can sell that energy back to the grid at night, almost like playing the stock market. There's some great software and hardware we're aware of, and one of the companies is Amber that lets you determine when you want to store your energy, when you're going to buy it back, and how much you're going to sell it for.
Okay.
So the whole transport sector is evolving.
Right. It's as you say, it's moving very quickly, and I suspect most people don't have any sense of how that's actually going to work. I mean, when you meet people and you tell them that you're working in hydrogen-powered vehicles, what sort of reaction do you get? What misconceptions are you aware of from the general public?
Yeah, a lot of curiosity. A lot of curiosity about the safety of hydrogen as well. Our tanks are about 1.5 inches, 2 inches thick of carbon fibre, and to test the tanks, we double the pressure. So we take them to 20,000 psi, and we pulse test them. We drop them from a crane, and then we put them in fire valves where they're building more pressure under heat, and we fire bullets at them. A modern car today, whether it be petrol, diesel, or CNG, is not going to pass the first test, let alone having bullets fired at it at twice operating pressure in a fire bath. So the technology is very safe, and the benefit of hydrogen, it's the smallest molecule in the universe. If it escapes, it's rising at it's just 40 tons lighter than air, so it's rising at 80 kilometers an hour. So it's very hard to contain hydrogen when it gets out. You know, it's a funny thing. People are always ready to kick hydrogen or electric vehicles, but if I was to go to the government today and say I'm going to stick 60 litres of a highly volatile liquid in the back of the car in a tank that's a 2 or 3 millimetres thick, in an exposed area, especially in a rear-end crash, you'd get laughed at and walked out of the office. But it's technology that's been around for over 100 years now. We've got used to it, but we are evolving away from that technology.
Okay. I mean, that's very true, isn't it? You're absolutely right. These, obviously, we're driving around in highly flammable vehicles that are likely to explode. And one of the concerns people have about EVs, of course, is when they catch fire, they can be hard to extinguish. That's not going to be a concern with a hydrogen-powered vehicle?
No, hydrogen-powered vehicles, we do significant testing. So I've seen testing where they've had anvils on a pendulum, so a big heavy weight on the pendulum, smashed in the back of the vehicle. The tanks have ended up from under the back of the vehicle up around where the driver's heads are and remained intact. I remember hearing a story of one of the Virgin Galactic aircraft that got to the edge of the atmosphere and broke apart, and the only thing to survive were the hydrogen tanks on the ground. So the tanks themselves I'm very confident with. I still get a bit nervous once in a while when I'm filling a vehicle at a service station with petrol, but I've had no fear of that anywhere in the world filling up a hydrogen car or charging electric vehicles, as a matter of fact.
Sure. WA has been positioning itself as a bit of a renewable hydrogen hub. What is it about WA, do you think, that might make it particularly suitable for hydrogen? I know we've talked about range anxiety, but I mean, is it the geography, the industry base, or is there just more will here, do you think?
I think there's geography is a big part in it. I mean, you've got a lot of long distances. I was up in Perth a couple of weeks ago, and I was up in Karratha and Port Hedland. I was looking at the roads and the assets that are using the road services up there and moving between those two cities. To decarbonise that freight is going to be very difficult, especially when you've got 3 or 4 trailers full of ore on the back of them. So you're going to need a technology, and EVs won't be able to do that job for one. Electric vehicles are impacted by extreme colds and heats as well, so that'll reduce the range in vehicles. Hydrogen hasn't got those same issues as EVs when it comes to that. But also those freight, everything that's moved on freight needs to move quickly, drop its load, go back to where it needs to go and pick up another load. Another opportunity with Western Australia is your location to Asia and the demand for Asia for hydrogen. So they're transforming their road transports and networks now, both road, rail, marine and air, and looking for someone to buy hydrogen off. So I think your side of the country is perfectly located to take advantage of those those nearby markets of Japan and Korea, Malaysia, Singapore, China, India, anywhere up there. And there's even talk of sending hydrogen from Western Australia across to Germany. There's been some offtake agreements discussed in that area. I think Australia is seen as a hydrogen superpower when it comes to production of hydrogen, and whether it's shipped out of Australia as a hydrogen gas or liquid hydrogen, or it's shipped out as ammonia. The CSIRO not only invented Wi-Fi, but they've come up, I think, with one of the world's best inventions, which was a metal membrane that can crack hydrogen into ammonia, or ammonia back into hydrogen. So we can make green ammonia in Australia, and there's certainly some big projects in Western Australia. I think the biggest production of ammonia, or second biggest in the world, is up at Port Hedland and Karratha. So that can be put on a ship as liquid ammonia, and when it reaches the port, say Korea or Japan, CSIRO technology can crack it back into hydrogen at the quality the cars need. So the benefit of that is that ammonia is already a tradable commodity. The ships exist, the ports exist, and the CSIRO has developed the key to transform it from ammonia back into hydrogen to use in transport applications.
It's amazing that it's, as you say, in the case of ammonia, the network is already there. The infrastructure exists for the shipping. I mean, how do you see hydrogen more broadly fitting into WA's transport ecosystem over the next decade, say?
I think buses are probably one of the biggest opportunities. In fact, one of the first bus trials in the world was in Perth 20 years ago plus. So a couple of buses that were sent down from Germany, they were tested in Perth. There was a hydrogen station that was built and then donated to the government or the bus depot. And from what I heard, when the project finished, everyone kind of put their hands in the air and said, hydrogen, how safe is this? And they pulled it down. So it was one of the only places in the world I'm aware of where a hydrogen project demonstrated the benefits of hydrogen. A station was left and then it was just pulled apart. I think bits of it are sitting in a museum somewhere.
I know there's currently only one refueling station in WA at the moment in Jandakot. I mean, what will it take, given that experience, I suppose, what would it take to expand that network statewide? Where's that going, the motivation to do that going to come from?
Yeah, I think looking at those hydrogen hubs and clusters, so looking at the major logistics depots, so looking at the decarbonisation needs to happen. So big businesses in Australia right now are looking at where their emissions come from. So everyone's looking at scope 1 and 2 emissions and how they can reduce their emissions with their businesses, especially some of the big businesses over in Western Australia. When they start looking at scope 3 and looking at transport and where their goods are coming from and how they're getting there, we're starting to see across the country now, not just in Perth, but around Australia, where big physical retailers are asking for their logistics companies to start decarbonising. And they're trialling electric trucks, and they're starting to trial hydrogen fuel cell trucks. It's only the tip of the iceberg. It's only a very small trial that's happening with those two technologies today. But as people are needing to decarbonise to meet their federal government requirements and to meet their own internal decarbonisation targets, there's a lot more needed to be done. And with that, hydrogen infrastructure takes a lot more time to put in than an EV charging station. Saying that, we're probably, as a country, not doing the best job with EV charging stations either. And I struggle when I go from state to state driving electric vehicles to find one charges in a convenient location. And unfortunately, one of the biggest problems is the chargers have been installed. A lot of them are inoperative. So we're certainly working with the federal government to look at some legislation that's been put in place in places like the UK, where charging station operators have got to have a 99% uptime,
right?
Which is really going to benefit consumers.
Okay, yeah, it would make a big difference, wouldn't it? Because there's nothing worse than turning up to recharge and it's out of order. And I've turned up at ones that you talk to someone nearby and they say, "Oh yeah, that's been out of order for a month."
I've had weeks. I live in the Blue Mountains. I drive down to Canberra, and I've had stations between Sydney and Canberra that were down at one stage for over 18 months.
Wow. Okay.
So that was a real concern. But I think there's an evolution happening. I think there's a lot more focus on the durability of the stations. We did have an Australian EV charging station manufacturer that built some amazing stations. And then they had some decision to make to move to the US. And unfortunately with that, they ran into problems and they went into liquidation, and it's been sold off now to a company in India. But those stations around Australia, when everyone back in Australian-made product, unfortunately, when they need repairs and not be able to get spare parts for them, so they've been needed to be replaced with something else. In most cases, that replacement has to come from overseas, which is a real shame for Australian manufacturing, Australian jobs, Australian engineering. So we want to really help support and see more Australian products made here.
One solution to the lack of infrastructure might be collaboration, which I think you touched on there. Hyundai and Toyota are normally fierce competitors. What made collaboration on hydrogen refueling infrastructure, what made that make sense?
Yeah, it's a non-competitive market, so it's something we needed to make sure that our competitors were there to justify the cost of a station. So no one can go to the federal government or ARENA or the state government and say, we'd like to get some funding to be able to put in a hydrogen station. It'll be a part private funded, part government funded project. And it was just one brand going there. It's a big risk. And we've seen that in Australia. We had some of the biggest stations in the world made down in Geelong. It was a project based off a Chinese startup truck manufacturer who promised to deliver a different truck to every project they'd got funding for in Australia. And unfortunately, they went bust before the projects are finished. And now those finished stations in Geelong and in Townsville now are looking for trucks. So we're working very hard to get more of our trucks here and some of our competitors to start running them off stations that have had significant private and government funding. So it's understanding the location of the station, understanding who the end user is, and having more than one manufacturer there. And that's why we created the Australian Hydrogen Transport Forum, and we'll invite every one of our competitors there. So we've got Toyota, BMW, and Photon trucks there today. Certainly we've had discussions with Daimler, with Volvo, and with PACCAR, who have DAF and Kenworth trucks. Hyundai will be more successful when we've got better competition, stronger competition in Australia. So I'm probably one of those rare people in the automotive industry who says, bring on the competition. I want more competition.
Right.
It's going to help me get more infrastructure on the ground a lot quicker. And we're going to see that there's kind of non-traditional, so there's different forms of bus manufacturing, both here in Australia and overseas, where they're looking to introduce hydrogen fuel cell buses today. And that really makes sense because a bus does the same routes every day. It's back to the same depots it's filling up. You know, when you invest in the money, you know the return you're going to be getting. So that's what you want, those high duty cycles. I said a hydrogen passenger car will take 6.33 kilos. Our car to do about 650 to 700 kilometers. So it might be back at that hydrogen station once every second week if you're lucky. A fuel cell truck or a fuel cell bus takes 34 to 64 kilos of hydrogen, depending on the size of the truck and the load it's carrying. It'll be back at a station every single day, especially if it's a back-to-base operation, which we're targeting initially. So the people investing in that station are going to get a return on their investment a lot quicker, knowing they've got a large volume of trucks or buses running off it. So we've got some trucks in Australia now. We've got some 40-ton rigid trucks. We've already announced publicly that Corgas are going to run one of those trucks off the Woodside station in Perth. Mm-hmm. There's a couple more of those trucks that are getting prepared in Australia now that are going off to the Perth station as well. We can't mention who they are. I think they want to do the launch themselves of their brands.
Fair enough.
We're starting to see a take-up of that. And that's the best way to get more infrastructure in Australia, is having more commercial vehicles running off these stations, because they're using far more gas in the car ever would. And they're generally back every single day to fill up.
Okay. So the purpose of the partnership really is to make sure there are more of these stations, which will ultimately make it easier to make hydrogen-powered vehicles more common, more of a reality for most Australians.
Yeah, share the load. I mean, Toyota's based in Victoria. They've got a station down there at the Altona, the former Camry manufacturing plant. It's a very big station. We've used that. They've used our station up here. I actually had a Mirai charging at our new hydrogen station here yesterday, and I understand the Japanese ambassador will be filling up his Mirai here shortly as well.
Yeah.
So we use each other with the infrastructure, and certainly I've used the infrastructure at Jandakot with ATCO, and any hydrogen station in Australia that comes on board, we'll be working hard to put our vehicles off it. Certainly, I'm going to deploy a lot more vehicles than Toyota and BMW and Photon. So we're still fierce competitors, but we need to make sure there's a number of manufacturers based off every station, in case one manufacturer decides to go in a different direction, like or has financial troubles like that startup truck manufacturer that left the market before they'd finished their required trucks for those projects.
Okay. So it's a weird kind of supply and demand relationship that you're working on here. So you're sort of generating supply in the hope that more supply increases demand, whereas it's usually the sort of other way around, really.
Yeah, exactly. Yeah. It's a tough one. And we've done that in Germany. Like I've got to work out of our office in Frankfurt a number of years ago, and there was one hydrogen station there at the time. It was pretty embarrassing. We'd taken over some Australian journalists to do a 1,000-kilometre drive across Germany to replicate Sydney, Canberra, Melbourne. So we drive them between between Frankfurt, Dusseldorf, Hamburg, and Berlin's 1,000 kilometers. Got to the station. I'd done some testing there the days in the lead up to the journalists arriving. The station was working fine, but there was only one in Frankfurt. Got there the day the journalists arrived with 3 or 4 empty cars, and the station was down. The nearest station, I think, was Munich or Stuttgart. So we had to put the trucks on put the cars on a truck and send them away. And we had to take the journalists to the Nurburgring for the day to get them to focus on something else. Like infrastructure and redundancy in infrastructure is critical, and that's why we're not focusing on. One of the things I learned in Germany, they started with a scattergun approach of one station in each city, where they realised fairly quickly they needed to have a hub or a network of stations in each city. So you had that redundancy. You can build the fleet and grow the fleet, and put more stations in when the fleet's got a lot larger. So that's a model we're trying to follow here in Australia, and certainly the discussions over the last 10 years and certainly the last couple of months in Parliament have been around how do we ensure that any investment, whether private or public, goes into a location where there are customers, where there is redundancy, where we can grow the fleet of trucks or buses or cars, and then work towards that decarbonisation of transport to meet the government's goals.
Okay. I mean, in terms of generating that supply that we're talking about, in terms of building more infrastructure, what are the key barriers to scaling hydrogen infrastructure at this point, and how are Hyundai and Toyota planning to tackle that?
Yeah, a lot of it was land initially, to find the right locations for it. There's about 7,000 service stations in Australia. They're really, generally they're there because they're in a convenient location. There's a portion of those that are dedicated to trucks. But usually you'll find on most service stations they don't have too much spare land around to put a 2 or 3 40-foot shipping containers. So you can package equipment down into a couple of 40-foot containers, so it can be modular and scalable and almost semi-mobile. But it's the space it takes up on service stations. So we haven't seen that in Australia. I have seen a lot of that in Europe and North America, but I haven't seen much of that in Australia. It hasn't been a focus on Australia yet. So you're looking for a greenfield site now anywhere in Australia. I'm assuming it's the same over in your part of the world. Real estate's extremely expensive, especially when it's on transport routes or near cities or near logistics hubs. So that's another one. It's the equipment's expensive as it is. Land is really prohibitive at the moment. So we're working closely with state and territory governments to look where we can identify land that's owned by the state, already set aside for logistics operations, whether that be large-scale truck rest areas. There's some being built on the East Coast now, where the trucking rest areas that don't have a service station attached, but they've got facilities for cooking and washrooms and different things for the truck drivers that run up and down the East Coast. Can we house a hydrogen station there? And we've seen it kind of vary in the last couple of years as well. Everyone focused on really large plants, really large equipment, and doing industrial-sized stations like what's being built by Woodside over in Western Australia now, and a couple of those have been built in Australia. There's a big focus now on smaller modular scalable stations. So in our plant, Hyundai's got plants in the United States. We've got a plant in Georgia. We've got a fleet of trucks running off that new EV production plant and battery plant in Georgia, where they've got mobile refueling stations where the OPEX and CAPEX of those stations is covered in the dollar cost of your hydrogen. So as our job is to operate the trucks and get our parts coming to the factories and help build the cars and then get the cars off the factory, we don't have to worry about the certification, the build, the commissioning, the maintenance, and ongoing supply of hydrogen to those stations. There's suppliers out there that will do it and embed all of that operational costs and CapEx cost into the dollar cost of hydrogen. So we're working with those companies in Australia. Mm-hmm. The funny thing about that company, it's started by 2 Australian guys in the US. The company's called 1H2. They have a number of investments from car manufacturers, GM and Honda and others in America, and some private equity funding. It's now been taken over by an Australian superannuation company, and they're looking to do those operations here. And there's one unit in Australia now. And I think they're the very best way to deploy those, can be put into a car park of a logistics centre that doesn't need very much space. And they'll have tube trailers where hydrogen's made somewhere else. Hopefully it's green hydrogen that comes on site. It's decanted into the trucks through the small refueling station. It's a 20-foot ISO skid. And then as the fleet of trucks builds, you can make those skids bigger. So our factory in America, we went to bigger and bigger modules. And now we're at the point now where we've got the fleet of trucks built up. We're ready to build our own large-scale permanent hydrogen refueling stations. and those modules and skids can be sent to the next project and the next project. So really, it's instead of building a mega hydrogen station and hoping the customers turn up, it's actually working for that first 5 and 10 trucks and building a small modular station that can be redeployed very easily when the more permanent stations build or the volume of trucks increases. That's where the focus around now.
It's about starting small and mobile.
Small and mobile, and it's also an asset. Instead of having a sunk asset in the ground, it's an asset you can pick up fairly quickly and put it onto a side load of a truck and move it to the next location. I got to work in New Zealand, look at the launch of a hydrogen station network there a couple of years ago, and they had some permanent stations on 40-foot ISO skids, on open shipping container skid with a hydrogen station on it. They can be dropped off the side of a truck like a container can today, and that gave you that mobile refueling station operation. And in that case, we had our truck running with New Zealand Post. It's still running there today. I think it's running a 24 hours cycle now, which is great because it can be refilled quickly. And they can get them back on the road and continue those deliveries of parcels across New Zealand.
Oh, fantastic. Well, good to hear that it's Australians leading the way overseas, and hopefully as a nation we'll be leading the way in hydrogen here as well soon. It would be great to talk a bit about the Hyundai NEXO, as you mentioned that a couple of times at the start, Scott. This is the flagship hydrogen vehicle for Hyundai. I mean, what's the NEXO like, and what sets it apart from petrol vehicles or EVs?
Yeah, it feels like when we have people that drive it, whether it be politicians or media or the public, we take it to a lot of EV drive days, and people go, I've come to an EV drive day, I'll take advantage and drive a hydrogen vehicle. It feels exactly like an electric vehicle to drive. It feels the same weight. The weight of the vehicle is all down low like an EV, and they've got EV electric motors, so the acceleration and the feeling exactly the same. We've actually come to the end of the production of our current NEXO that finished production early this year. The new vehicle's in production now, shortly. We have our first pre-production vehicle arriving in the next couple of days. Unfortunately, I'm heading away on long service leave, so I won't see it. So I've been
it's bad timing.
chomping at the window every time I hear a truck pull up to see if the car's arrived. So we'll do testing here in the suspension, looking at the dynamics of the vehicle, looking at the active and passive safety features, and doing some of that final certification work. And that'll go into production very early next year. And we've got some customers very interested in that vehicle. But certainly our vehicles we had deployed in the ACT government, some of those are coming off that project now. It was initial 3-year project, went to a 4th year, now it's into its 5th year. And those vehicles are coming back now. And we've got more than enough customers that want a second-hand vehicle. So we're servicing those vehicles. We're redeploying them. About 6 of them are coming to Perth. And we've got a number of vehicles going down to the Geelong site with Viva Energy Shell. We've got vehicles going up to Brisbane and Townsville. So if I had another 50 of those, I could get rid of them at the drop of a hat. So there's a lot of interest in it, and certainly be able to get into a vehicle that's already done its life somewhere with the government fleet, and in some cases, unfortunately, underused. Coming back with fairly low kilometres, we've got a very, very attractive rate on those vehicles to get them into big industry and governments, and so people can start to see what a hydrogen vehicle can do and how it interacts with those fleets. So a lot of those companies have taken them on. We've got a couple of ports taking the vehicles. So we've got universities, we've got local councils, we've got some of the big hydrogen station operators, so some of the big energy and gas companies that are taking them on. And I understand that our competitors doing a similar thing. I just need to act a bit quicker than them and get my cars locked into those customers before they get there.
Yeah.
So the market's still very competitive, and Hyundai and Toyota will keep bashing themselves in the head when it comes to whether it be EVs or fuel cells.
So at the moment, who's driving these NEXOs? It's just companies, it's universities, it's government.
Yeah, it's mainly big companies. Initially, it was government. So there was 20 cars deployed with the ACT government. There was 5 with the Queensland government, and they were used by politicians moving around from Parliament around Brisbane. They're also used by the Queensland Police initially. In Canberra, it was used by half a dozen different departments are using it, from fire, from nurses doing community visits to residents, and across the different departments in operational departments in the ACT government. We had vehicles with the Korean Embassy. Woodside had a vehicle in Canberra for a long time, but that vehicle's heading across to Perth now because their station's getting close. So no shortage of customers, and Toyota had a fleet of vehicles actually deployed in Perth for quite a while. I think there was 15 or 20 vehicles with Toyota deployed with a number of companies in in Perth, I think it was Woodside, Fortescue, and Atco Gas had cars as well.
Okay.
And I think they may have some cars with the government in Western Australia. So far, there's a big market out there. We haven't had to cross paths too often. I mean, we kind of dominated Queensland and the ACT. They dominated Victoria and Perth, but we know there's a lot more customers out there, and we welcome competition. We know that BMW is part of the Transport Forum. They've had vehicles here testing in Australia, and certainly we're looking forward to seeing more BMWs coming to Australia. We're aware of at least 2 other brands, passenger vehicle brands, that are coming to Australia with vehicles. So if we can help in any way with what we learned around technician certification, workshop certification, fire and rescue training, anything to deploy the vehicles to try and get more competition here. We've done the same thing with electric initially when we started technical training for our workshops, and workshops have to be set up differently for EV charging and EV bays, and you need certain matting on the floor and insulated flooring and insulated hoists and different things. The same with EVs. Same with fuel cell vehicles. We need to train our technicians a little bit differently, but they can be serviced in a normal dealership.
Okay. You said the experience of driving the NEXO is very much like driving in an EV. 2 of the concerns that people have about EVs, I suppose, are the range anxiety that we've talked about already, but also the resale value because the technology is moving on so quickly. Are those 2 things that you don't see affecting hydrogen vehicles to the same extent?
We haven't sold hydrogen cars in Australia, so we leased them all out. So all the vehicles have been deployed in Australia, been leased bar one, and that went to an embassy, and under their global rules and regulations, they couldn't lease a vehicle, so that was sold to the embassy. So all those other vehicles, the great thing about that is we control the vehicles at the end of the day. When they come back to the end of the lease, we managed to find homes for all of those cars that are coming back, and certainly got a lot of interest from customers who don't just want one car, they want fleets of 4, 5 and 6, which has been really interesting. But we certainly want to give a spread of cars to as many customers as we can, because we want them to try and fuel the current vehicle that's now into its 5th or 6th year.
Okay.
And then get them into the new vehicle when it arrives next year.
But so you think a second-hand NEXO might be more attractive as the years go on than a second-hand EV?
It's hard to tell. I mean, potentially. I don't know what I'd sell a second-hand one for. We were basically releasing them again, so we're not selling the second-hand ones.
Sure.
EVs, we're starting to see the price change in second-hand EVs and starting to grow now. I think initially there was a concern about batteries, and probably one of the things as a manufacturer, or all manufacturers haven't done, is talk about the reliability of batteries. There's certainly the batteries in Hyundai Motor Group vehicles, so that's across Hyundai, Kia and Genesis, have very good batteries made with some great suppliers that Hyundai's been working with for years. So we can go through, and in our training centres and workshops here, we've got training centres in Perth and in Melbourne and in Brisbane. We go through and we can go diagnose individual cells in the battery. 3 cells make a pack, and then I might have 8 or 10 cells make a module. There might be 12 modules in the car. So we can diagnose cell, pack and module. We can replace a cell or a module in a pack. And we've got a machine where we rebalance those. So what people don't know, people always worry about what's going to happen with my battery at the end of its life. We warrant our batteries longer than we warrant the cars.
Right.
The battery's got an 8-year warranty. The car's got a 7-year warranty. So, and the batteries can be popped. So you can have a battery out of a vehicle in about 20 minutes on a special hoist that brings them down under the vehicle. We can pop the lid off in another 10 minutes, and there's a reusable seal. Our battery, I'm not sure about our competitors, but certainly Hyundai batteries, we can open them up. We can replace cells, packs, or modules. We can put them back in and get the battery back in the vehicle on its way. We don't see a big issue with batteries that are going to be sitting around after their life and not being able to use for anything. We can recycle batteries and use all those same components. You might have 5 or 10 computers in the batteries, cooling systems. The batteries are so thick in the frame, the aluminium frames of the batteries, and the way they bolt into the vehicle give the vehicle a structural rigidity. So in a frontal side or rear end and crash, the battery frame itself helps protect the occupants in the vehicles. So as long as the integrity of the frame of the batteries intact, we can go through and upgrade, upcycle those batteries and keep them in the cars for as long as possible, and keep those cars into their 2nd, 3rd, and 4th lives, like you see with internal combustion vehicles today. There's no reason why EVs can't be doing exactly the same as that. And again, I won't speak on behalf of our competitors. I don't know what tech they're using and how advanced they are, but certainly from the technology we're using, we can certainly do that.
Okay, well, that's obviously promising for those of us that have splashed out on an EV. Hyundai's talked about hydrogen society where transport, homes, and industry are linked. I mean, how far off do you see that vision as being in Australia?
Yeah, we've seen that there's projects going on in Korea now, and certainly even larger scale project going on in Japan, where they call them hydrogen cities, where they're looking at as much transport, so passenger transport, commercial, public transport, trains. We're lucky enough within the Hyundai Motor Group. We are one of the only manufacturer in the world that builds cars, trucks, buses, trams, trains, ferries, and we're one of the biggest commercial shipbuilders in the world. We build everything when it comes to ships, except for we don't build cruise ships. We build about everything else. So we're looking at how we decarbonize all forms of transport. So the hydrogen fuel cell stack in a vehicle is a 90 kilowatt stack. We've got new stacks coming. I think we're in generation 2 now. The vehicle coming goes to generation 2.5. And then our next generation trucks go into a new generation stack, which will be much larger. Much higher capacity, but actually reduce the size of those stacks. A lot of it comes with stacks as packaging and how you package them into a vehicle, or on top of a tram, or on top of a bus, or in a ship, or a boat, or a ferry. So packaging is critical. So if you think about, it's probably a bit of a crude way of saying it, but a fuel cell stack, a 90 kilowatt stack, is about the size of a carton of beer or a carton of long necks of beer. So that's a 90 kilowatt stack. So in a car, we've got one. In a truck, we'll have 2 of those. Larger trucks may have 3, and in ships you may have, and trains you may have 10 or 12 or 14. Ships you may have a couple of hundred. So it's almost like stacking Lego together. You can put more stacks together, and all we need to do is know how much horsepower or how much kilowatts you need to propel your machinery. We know there's hydrogen forklifts around the world now. There's hydrogen stationary generators that both we've got, Toyota's got, and other companies have got them. The same fuel cell stack can go from powering your vehicle to powering a truck, a bus, a ship, a train, or powering your home, or powering cities. So when they talk about a hydrogen society, it's that one stack with, our current stacks are a 90 kilowatt stack with 440 plates inside them. There's an anode, a cathode, and a membrane inside. And they kind of they spread out across the stack. There's no moving parts in there. So that chemical reaction that takes place when the hydrogen comes in and mixes the oxygen, and it breaks down, and the water goes out the vehicle, so the purified air and the energy goes into the electric motor and powers the motor. That can be replicated across all forms, not just transport, but also stationary energy. So that's where the technology is so amazing, and fuel cell stacks are such an amazing piece of technology, where that one box about the size of a carton of beer can power anything.
I suspect that if you're wanting to explain this technology to Australians, using the analogy of a carton of beer might be a really good place to start.
What he says about that 6 boxes of shoes my wife went out and bought last night for our trip.
Right.
That's probably another analogy.
Okay.
So one of the amazing things is that hydrogen is not new either. We knew about hydrogen in some early tractors in the late 1800s. In the 50s and 60s, in the Apollo and Gemini space programs, hydrogen was used to power all the electronics in the spacecraft, and the astronauts drank the water. There's a great video, actually. It's that Hyundai put out about the technology, looking at what Pratt & Whitney done back in the space age and the space race by using fuel cell stacks. So the technologies evolved from that into what it is today, where we're going to see it across all forms of transport.
Okay. And how critical is government support to this? If you could wave a magic wand and change one policy or even perception around hydrogen-powered vehicles, hydrogen fuel cells, what would that be?
And it'd probably be that we spend, there's some great funding out there for hydrogen projects across state and federal governments, but everyone wanted to build the world's biggest hydrogen production. And there's obviously some big companies over in Perth that had some big plans of 10 megawatts, 20 megawatts, even larger. No one had done projects that size anywhere in the world, but everyone was kind of rubbing their hands together, think we're going to make these massive projects. It's great to make projects making thousands of tons of hydrogen, but you've got to have the off-takers for it. So I think we've moved away from the obsession with building the world's biggest X to building what do we need to build today to power a fleet of buses or trucks today in a depot that can be shared. So a few of the projects that we're looking at now is having smaller scalable hydrogen stations at a bus depot where the buses can fill on one side of the fence and trucks and passenger cars can fill on the other side of the fence. And we've seen those projects with Shell in countries in Europe and through Norway and other places have got those. So how do we use that one piece of infrastructure to fill as many different products as possible? So we're looking at, we also build trains, and we've got a train factory going into Maribor in Queensland now for the trains for the Queensland government for the Olympics. Once that's done, could we use that factory for hydrogen trams? We've got hydrogen trams being built in Korea now. We're looking at deploying hydrogen trams in Australia. So could we put a tram, a network somewhere with hydrogen fuel for trams, and at the end of that line where the trams are filled up at night, can we fill up the public buses on that same piece of infrastructure, and trucks and courier vehicles or passenger cars? So it's looking at the best location for infrastructure, the best spend for public and private funding, and building the right bit of equipment that's going to suit today's needs. Not building the world's biggest and best station and then looking at where the customers are. And I think we've learned a lot. And I think we're going to move into a time now where we're going to be building scalable equipment where we can provide equipment that's the perfect size for today, but having a scalable modular, so it's not hard to increase the capacity to 2, 3, 4, 5 times its capacity over the next 10 years, which I think is a much better spend of public funds.
Okay. We've talked today about how the shift towards hydrogen is probably going to be driven by government fleets or logistics companies, but I suspect that many people listening or watching this podcast will be wanting to know when they can get a hydrogen vehicle. I mean, how close do you think we are to seeing hydrogen vehicles available for general consumers in showrooms?
Well, we'd love to be able to put them in general consumers' hands in Australia. Certainly, we've done that in America. A lot of that was done in California. We've got it in a number of countries across Europe, and in Korea, there's a massive fleet of hydrogen vehicles in public hands. The biggest problem we've got in Australia at the moment, infrastructure, both EVs and hydrogen, has been very slow, but exceptionally slow with hydrogen. I don't want to put cars into public hands until I know I've got a station or a network of stations in a similar location. So what do the first 3 stations look like around Perth, and how can I get not just corporate cars into those, but how can I get public, private people in driving those stations? So it's ensuring that they have a good experience when driving a hydrogen fuel cell vehicle. And to do that, you need a network of stations. And at the moment, we don't have that anywhere in Australia.
Okay.
It's coming, and there's a lot of plans for it. There's 9 stations operational in Australia now. We did take any of the advice from Germany. We've done a scattergun approach and put a station nearly in each state and territory. Now we need to build out that network of stations around those those original key stations. We need to build out the network around those.
Okay. Let's say that network exists in 5-10 years. Battery EV, hydrogen car, petrol vehicle. Which one are you going to choose to, say, drive across the Nullarbor?
If I was stations across the Nullarbor, I'd jump into a hydrogen car straight away, because I could go from station to station, fill up in a couple of minutes and keep driving rather than waiting around for an hour or 2. I can get you out quicker. That's, I suppose, one of the benefits we didn't mention earlier when you said the benefits between EV and hydrogen. I find a lot on the East Coast here where we do a great job of putting in 2 stations only, EV chargers only, pat ourselves on the back and move on to the next location. Where in Europe, and I've got the chance to work over there, they'll build 10 and 20 in the same location,
right?
Pat themselves on the back and say, that's not enough, let's build more in the same place or on the other side of town. It's very frustrating in Australia when you go to an EV charger, 1, if they're not blocked by a petrol car, 2, if the stations are taken up, or 3, one might be down. So the benefit of hydrogen is you can go in and fill up at the same time as a petrol car it takes to fill up, and then move on. So you're not blocking the bay up for a couple of hours whilst you're charging an EV. And I think you mentioned you're driving an EV. You probably feel the frustrations that are out there, but it is getting better in Australia. We are working very closely with the federal government to come up with some rules around the blocking of bays by internal combustion vehicles, by having very high uptime required by the network operators, the EV charging station operators, getting a sense of consistent way of paying. So at the moment, we actually had test teams here in Australia. Just finished with Hyundai test teams last night, looking at what we do with charging in the future. I've got 9 apps. I've actually I've got 13 apps now on my phone for EV charging on the East Coast. I've got EV Jet Charge, BP Pulse, Charge Fox, Explorer, and Ampol. I've got Tesla Jolt and another one for Autel. So I've got my credit card on. What's that? 9, 10, 11, 12 different apps.
Right.
So we don't have that consistency. And I remember speaking to, back at the time, he was the chief financial officer for Arena, and he asked about what we should be looking at when it comes to supporting EV charging in Australia. So one of the lessons learned from Europe, and we should be learning all our lessons from Europe, don't do the same mistake twice, is how do we have one form of payment? How do we have one card or app that I can use at any station across Australia? And one of my frustrations with EV charging sometimes is you go to a station and I don't have an RFID card for the 12 different branded stations I use. So I just use the app. But I've been in places, given that we've got such awesome phone connectivity in Australia and there's service everywhere, I've been stuck where I couldn't charge a car because the local mobile phone tower was down or the very low reception. I'm trying to get a charging situation happening. But
Yeah.
there's a lot of that's changing, and a lot of it's just getting the right rules and regulations in place to ensure that consumers have the very best experience in Australia. And a lot of that's just learning what's happened in Europe over the last 10, 15 years for both EV and hydrogen. Bring those learnings back to Australia, save money, and do it right the first time.
Now, Scott, we started talking about the fact that looking at the future of motoring, it seems that EV are way out in front. It's become a one-horse race. Now, I don't want to encourage, but if you were to put money on this, if we circled back to this conversation in 10 years' time and we were talking about one mode of car having become dominant, which one do you think it's going to be?
For passenger vehicles, it will be EV, 100%.
Yep. Okay.
So as emission regulations cut in, and the listeners may not be aware that Australia, up until January this year, didn't have emission regulations. Within the OECD, there's only 2 countries that didn't have emission regulations, which was Australia and Russia. So it's something that both sides of politics are working on, and the market needed it. And the manufacturers, we needed a line in the sand to know what the future was. We planned cars 5 and 10 years out, from resourcing to production line capacity to the different technologies that are needed. And then you've got the critical minerals behind all of that. We needed certainty. So the industry wanted emission regulations. We finally got it now. So January 1 this year, emission regulations came into place in Australia finally. And as of July 1 this year, manufacturers started absorbing either credits or penalties. And you need to adjust your fleet mix to meet that transition between now and 2035. By the time we get to 27, 28, even hybrid vehicles don't get you the credits you need to be able to get below the penalty line. So you'll see a lot more plug-in hybrid and EVs coming in the coming years, and especially the last 5 years. And what we've seen, even before the emission regulations came into play, we've seen a lot more competition come into Australia and a lot more consumer choice, which is really what the motoring clubs have been fighting for. And my time at NRMA for 10 years, writing for the magazines and talking to people about technology, it's taking a very long time to get to here. And I've been here with Hyundai 15 years now. So, 25 years ago, we were pushing and talking about this, trying to get EVs happening in Australia.
Mm-hmm. All right, so passenger vehicles, EVs, fleets, possibly hydrogen. You do see it's just going to be that, as you say, the sort of petrol-diesel split between EV and hydrogen.
It will, yeah, and I think you're going to see a lot more in commercial fleets will be hydrogen, and especially when there's hydrogen stations on depots and sites. So we're seeing it at our own sites in America with our own factories, we've got our own stations. We're going to see that more in Australia. And certainly we're being contacted by some of the big logistics companies, some of the big online retailers who are already doing this on their sites in either Europe or the US or in Asia, where they're saying we want to start decarbonising. We've got a fleet of 500 trucks. We're going to start with the first 5. What does that look like? Because they're going to be penalised. Emission regulations for trucks will come into play. Some of our conversations in Canberra last week were about emission regulations for trucks. It won't be the same as cars. There'll be more of a carrot and stick approach. And one of the things I emphasise with that is that for trucks, and whether it's EV trucks or fuel cell trucks, infrastructure is critical. We know that the big high capacity megawatt chargers they got in Europe take a lot of energy to power those chargers. We've got 350 kilowatt chargers in Australia today that can almost black out small towns if something happens, let alone a one megawatt charger. So I think they're going to be very, very difficult to install in Australia. Those really high capacity chargers to get the trucks back on the road within an hour or two. So really planning for hydrogen refilling infrastructure and ensuring that when it goes in, it's servicing as many transport modes as possible.
All right. Scott, thank you. I hope we can circle back to this conversation in 10 years and we'll see how it's all panned out. Hopefully it's all gone to plan.
There's always something evolving and something happening, and certainly we've launched 2 electric cars this year. Next year we're launching a hydrogen fuel cell car and another electric car. There's plenty of competitors out there launching cars every other week. So the industry in Australia is evolving rapidly. I remember when I was writing for the motoring clubs many years ago for Best Car Awards, you could identify every car on the road. I mean, even myself now as a bit of a car enthusiast, I struggle to identify some of the new vehicles coming in, but it shows that things are evolving and things are changing. What we've done 20 years ago with the 3 local manufacturers is completely different to what we have today. And certainly the tech in the vehicles, the environmental performance of the vehicles, and also the occupant, the active and passive safety features to protect the occupants and pedestrians is exceptional. And we've got much safer, much cleaner cars than we ever had. So it's evolving quickly, but circling back in the next 5 or 10 years to see how the whole industry's evolved when emission regulations have cut right in and commercial vehicle regulations come in, it's going to be a whole new world.
Well, I look forward to that. But in the meantime, Scott Nargar, thank you very much.
Thank you very much. Have a good day.
Thank you for tuning in. If you liked this episode, let us know and share it with a friend. Don't forget to hit subscribe, and we'll catch you in the next episode of RAC's Horizons podcast.